Good day, students. I am Dr. Godwin Al Hassan of the Department of Crop and Soil Sciences, Faculty of Agricultural Sciences, National Open University of Nigeria. Our topic today is on availability of micronutrients. Micronutrients in the soil include boron, sodium, chlorine, iron, manganese, etc., etc. The forms that are appearing in the soil may not in the form that are available for plant use. And so we are going to look at the various forms that these micronutrients will be made available for plant use. Also, we are going to look at the factors that affect the availability of these micronutrients. It is an interesting course. I want you to feel free to ask questions along the line as I take you through the slides. God bless you. Uh, you are welcome to our regular course on SLM 305, and our topic today is availability of micronutrients. These micronutrients include boron, iron, manganese, molybdenum, zinc, copper, chlorine, and sodium. Our objectives include we are going to mention the specific soil factors that determine the availability of boron, iron, manganese, molybdenum, zinc, copper, chlorine, and sodium. Let's start with boron. Boron is a light non-metal occurring in soil as a borosilicate and as a tourmaline. The main boron-containing minerals are in these two that I have mentioned. Its deficiency has been reported in legumes, root crops, and fruit crops. Deficiency symptoms include breakdown of internal tissue or roots, death of terminal buds, brittle leaves, shortened internode, abnormal short plant. Older leaves become chloristic. What are the functions of boron? Boron acts very well for transportation of sugars, for terminal bud growth, and it is responsible for enzyme activation. This picture you are seeing is the picture of boron deficiency in pawpaw with a lot of lumps appearing at the fruiting portion. Factors affecting boron availability: organic matter content of the soil, high organic matter, high boron. Clay content, that is the texture. Heavy soils contain more boron than light soils. Soil pH, boron availability drops at a pH level greater than 6.5. Soil moisture, boron availability drops under dry soil conditions. Iron. Total amount in soil in earth crust is high, but not related to its availability. The role of iron. It is required by some enzymes and cytochromes. It is associated with chloroplast proteins. Deficiency. Always been associated with high pH, high calcium carbonate, or both. Iron is immobile. Symptom of chlorosis and stunted growth is first noticed on the upper younger leaves. Presence of iron. Iron occurs in the following minerals: hematite, magnetite, ferrous carbonate, iron ferrite, and limonite. The primary minerals as biotite, chlorides, and olivine, etc. Factors affecting iron availability. Soil pH is one. Iron reduces with increasing pH. Ratio of iron to magnesium. Increasing magnesium level causes iron deficiency. High concentration of P may cause iron chlorosis. Excess bicarbonate, free calcium carbonate also affects the availability. High levels of zinc, copper, and manganese. High soil moisture and poor soil aeration. Manganese and molybdenum. Manganese and molybdenum are micronutrients. needed by plants in minute quantities. Deficiency affects the productivity of crops. Manganese. Manganese is similar to iron in many respects. It is immobile. Manganese is absorbed by plant as ion 2 positive. It occurs in minerals like bronite, magnetite, and augite, etc. Functions of manganese. It acts as catalyst in several important enzymic reactions. It helps in carbohydrate metabolism. It also helps in phosphorylation and a citric acid cycle. It is an important activating component involved in N metabolism. Factors affecting availability of manganese. High organic matter leads to availability. Improvements of humid acid soil, that is the humus soils. At high pH, fixation of manganese occurs. Under waterlogged condition, manganese 2 becomes more soluble and more available. Deficiency symptoms. Manganese is immobile. The deficiency shows in form of grayish coloration near the base of younger leaves, necrotic spots, and wrinkled leaf formation. Molybdenum, MO. In contrast to nitrogen deficiency, necrotic spores appear at the leaf margins because of nitrate accumulation. Availability of MO. MO occurs in several oxidation states as +2 and +3. It is the only micronutrient available in alkaline condition. Functions of molybdenum. It is required as enzyme activator, helps in the fixation of atmospheric nitrogen. It has positive relationship with nodulation. It is required as ascorbic acid synthesis. Factors affecting availability of molybdenum. In acid soils with high iron and aluminum oxides, these oxides form crystals which exclude MO. Soil texture, clay soils. Soil texture. Clay soils are known to absorb MO in acid soils. MO is easily released at high pH. High nitrate content reduces the level of availability of molybdenum. Availability of zinc, copper, chlorine, and sodium. Zinc occurs in nature as zinc sulfide. It is absorbed by plant as a zinc sulfide +2. It is a metal activator of enzymes. It is vital for carbohydrate transportation from roots to other parts of the plant. It aids in the formation of auxins, plant growth hormones. Zinc promotes the absorption of water by plants. Factors affecting availability of zinc. pH. Zinc is more available at low pH. High P content may induce zinc deficiency. Zinc is part of organic matter. Too much organic matter may make zinc unavailable. Copper, Cu. Absorbed by plant as copper 2 positive. 99% of the air crest has copper in impure form. As sulfide and oxide, copper serves as fungicides or germicides. It is toxic to lower forms of life, and that is why it is used as fungicides or germicides. Copper helps as an activator in enzyme system. It is a precursor of chlorophyll, but not part of the chlorophyll molecule. Copper inactivates certain toxins produced by certain fungi and bacteria. Copper is also associated with nitrogen fixation and mineralization. Factors affecting copper availability. pH, copper availability increases with a decrease in pH. Organic matter, organic absorption ties up a lot of copper and nutrient interaction. Chlorine and sodium. It is recently found to be essential. It is required in very small quantity. The problem is usually with its excess rather than its deficiency. It is usually in form of a calcium chloride or magnesium chloride. In excess, it affects the quality of some crops like tobacco leaves and the soil quality of potato and yam. Sodium recently found essential is found as an essential nutrient in plants like tomato. Thank you and God bless you. See you next week.